few years back, I discovered a very smart way of doing these experiments. And as you've guessed it right, this is the smart device, which does so much of smart work for us. There's so much of smart applications. And I didn't know that we could actually perform so many experiments in such a fun way, in such an easy way. You know, with certain experiments, certain measurements which we require to make in physics applications required a lot of costly equipment. And here it's almost a cost-free device. And we can make measurements which are otherwise not possible in a conventional lab setup. So we will be, as a team, we have Gayatri, Maurya, and Kashvi with me. So we will be sharing some basic experiments that can be performed using some applications in the phone. And remember, this is just a trigger for you. These are just some examples, but in your own creative way, please keep exploring what else you can do, right? So let us start. I will share my screen.
Neeraj, I just want to make one announcement.
Yeah.
All participants, any queries you can write in chat box. Me and Rishabh are continuously, and Gulfam sir are looking at chat box so that we can take your questions at it.
Yeah, we have physics faculty here. We can talk about it. Otherwise, in the end, we will take up the questions, right?
Right.
Just a minute. I'm not able to present my screen. Wait. Just give me a minute, please. Technology has its own disadvantages also. I was trying to use a dual screen, but somehow it's not working. So I'll come back to this screen. Yeah. So Vinita, just let me know if you can see my screen.
Yes, we can see.
Yeah.
Over to you.
So let's grab our smartphones or iPads, whatever we have with us, and do some fun experiments. You can actually do the experiments along with us. Yeah. So did you know that our phone has almost, any average phone has at least 10 sensors? You know, when you keep your phone near your ear, then why is that the screen gets locked? It is because of the proximity sensor. How does the phone adjust itself in the landscape or portrait mode? That is due to the accelerometer. Also, if you have noticed that when you are in bright sunlight outside, your phone screen goes dim. That is because of the light sensor. So we have number of sensors, and these sensors can be used to perform some physics experiments. So in fact, some years back, I discovered this wonderful app which can generate sound of different frequencies. And this was a wonderful, fascinating way to demonstrate the concept of beats that we study in grade 11. I hope there are some grade 11 students also with us. They would understand what I'm talking about. So I am talking about having an application PA tone in my phone. And when I open this application, this is the kind of screen that appears. And we can, using this application, I can generate frequencies, sound of different frequencies. So here I have two phones. On those two phones, I have opened this application, and in one of the phones I will have a frequency of 356 hertz, and in the other phone I have a frequency of 359 hertz. And observe what happens. So this is the first frequency. This is the second frequency. Now they are sounded together. You noticed when I increased one of the frequencies, what happened? So what are beats? Beats are these alternate variations in the amplitude of sound which are produced when two sounds of almost close frequency, nearby frequencies, are sounded together. So you just saw that the frequency of the beats which were produced. Beats are these alternate variations in the amplitude. Thus, beats is what we heard when both these sounds were sounded together. And the frequency of those beats increased when I changed one of these frequencies. This is because, I'm sure you all know. Anybody would like to comment on that? Do we have any grade 11 students out here? Why did the frequency of the beats change or increase when I increased one of the frequencies?
So you can unmute and answer if you wish.
Yes, please.
You can speak in terms of formula if you want.
Okay, no problem. Maybe we don't have grade 11 students at the moment, so you'll be studying this phenomena in grade 11. Actually, the frequency of the beats that we hear is equal to the difference in the frequencies of the two sounding notes. And when the difference increased, the beat frequency also increased. So that was a fascinating way of actually demonstrating to the children and making measurement using this phenomena of beats. Okay, next I move on to another application which I discovered, which is called sound meter. This sound meter can actually measure the decibel levels of the sound produced. Okay, so this can be used to perform many investigations. Like I thought of one investigation where I have a sound producing device, like this is a Bluetooth speaker, which I can remotely control and play any particular sound of any particular music or anything. And I want to investigate the sound absorbing the properties of sound absorbing materials. So I could actually place layers of these corrugated sheets or any other material, and then try to figure out how the decibel levels change with the change in the material or the layers of a particular material. So that is one of the investigations that can be done using this sound meter. You can think of many more. In fact, there is no limit to what all we can do. It's just that it's all your creativity. We are just giving you or telling you about these tools which can be used for doing number of different experiments. So but then these days we came across some applications which have number of sensors clubbed into one. So if you can actually download Arduino Science Journal. We will be explaining how you can perform experiments using different sensors which are available in Arduino Science Journal. So the applications that I was talking about earlier had only one, application. It could either produce a frequency of different, of different nodes, and there was another sound meter which could just record the loudness levels of the sound produced. But Arduino Science Journal and phyphox have number of sensors clubbed together, and they are very simple to use, and we can perform number of experiments using the sensors in particular application only. So you can download this, and we can move ahead to perform some basic experiments using first Arduino Science Journal and then phyphox. So in Arduino Science Journal, when you download, this is the screen that appears. And then you just press on the add button. And then the screen which appears has this where you have sensors written. So press on sensors, and then you will get the various sensors which are available. One is the light sensor. There is this decibel meter or sound intensity that can measure. Then there is application which can measure the frequency which is produced. And then there are accelerometer. In fact, there is magnetometer also. You can measure the magnetic field strength as well. Okay, so if you press this, then the decibel meter opens. And next, if you press on this one, then this application opens. This sensor which will be activated will be measuring the frequencies, the notes of different frequencies. It will record that. You can press on the record button and the data will be collected. In fact, there is this new application which has come, which is like you can add sensor. That means you can operate two sensors at the same time. If you want to measure the decibel levels as well as the frequency of a sound, then that can also be done. So there is there is one experiment that I performed using the Lux Meter, which is the light sensor. And this can record the intensity of the light which is there. So if you have downloaded this application, try locating the light sensor in your phone. Where do you think is the light sensor? If you press on the light sensor, what do you see? What will be the reading here? You'll see 0 lux if you hide the light sensor. I'm sure you know what I'm talking about, where the light sensor is. So using this light sensor, I performed a simple experiment. There is a LED bulb that I took, which is a 14 watt. And this is just a way of holding the phone at a place using a selfie stick. And the light sensor, this camera, is kept at such a height so that it is just opposite to the center of the bulb. And then I marked these pointers at 5 centimeter distance, and I'm going to place this phone exactly at 5 centimeter different distance after keeping it at a position for a few seconds. And what do we expect to see? How do you think the light intensity will change when I move the phone away from the bulb? Remember, one precaution that I had to take was that I had to perform this experiment at 10 o'clock at night, so that there is no other light which the phone senses. Remember, these sensors are really sensitive. They can sense the light which is there around it also. But I was most interested in light coming from this particular bulb. Also, I wanted to avoid the light reflected from the walls, which may be falling on the light sensor. And so therefore, I had to move the table slightly away from the walls so that not much light would be, detected by the light sensor. Although I couldn't completely avoid it, but the investigation that I wanted to do, how the intensity will change with distance, is something that I was able to do with appreciable precision. And you see, this is the data that I got. This is like when the phone was at 5 centimeter, the intensity was about 15 kilolux. And when the distance increased by 5 centimeter, it was reduced to almost 1/4 of the intensity here. You can even see the graph here. So it's like for the time, this is time axis. For the time when I kept the phone at 5 centimeter mark, this was the intensity. It was almost constant. You can see some, shaking here. Maybe that is like where my hand was shaky, or I couldn't keep it very still. But we can devise some method where the phone is exactly, not able to move. Then when I increased the distance to 10 centimeter, the intensity decreased to almost 4 kilolux. And similarly, after that, this was the pattern which was seen. And this is what we call as inverse square law. That means the intensity of light is inversely proportional to the square of the distance from the source of light. You can understand that actually as you move farther away, the light is spread. And when the light spread, the intensity reduces. And that's what I could prove so easily without any actual manual plotting of any graph. In a jiffy I was able to do. So this is one example of the experiment that you can do using this ambient light sensor in Arduino Science Journal app. Then there is another experiment that I performed, which was to prove Malicious Law. If you are in grade 11, you must have studied this law, which is like you use two polarides. One is used to polarize the light which is falling on it. The other one is used to analyze the light. And when this polaride is turned around, it's moved, and the angle between the polarizer and analyzer changes, the intensity changes in this manner. That is, when the two polarides are parallel to each other, the intensity is maximum. And when the other polaride, which we are calling as analyzer, it turns by 90 degree, then the intensity is reduced to 0. And this is the variation is observed when the analyzer is turned by this angle from 0 to 90 and so on with respect to the polarizer. So if you can see on my phone, on the camera point where the light sensor lies, I have stuck a Polaroid sheet, which was nothing but like a simple, if you've gone to watch 3D movies, there you get those specs. I just took a cutout from there and pasted on my phone, and then observe what I did. So again, I'm holding the phone with my selfie stick, and then I've turned the phone towards the screen of my laptop, and I'm turning it around from 0 angle to the screen and then 90 degree. What do you predict? What will happen?
Also, need to ask them that what actually screen is made up of.
Yeah, that's what. So if you see, you saw that the variation was just like the cosine curve that I had shown you. This is because, why do you think? I've just used one polarizer. So what is happening? Can you think of it? Can you think of what is happening? Why is I talked about two polarized sheet, but I had used only one polarized sheet on my camera. So what can you guess? Yes, anyone? Okay, so this is because the screen of your laptop is also emitting polarized light. It polarizes the light. So the light which is coming from your screen is already polarized. And that polarized light, when falls on this other polaride, which is the analyzer, then, and when you're turning the analyzer, then you observe the variation of intensity of light, which I have done using this ambient light sensor. Okay. So we move on to next application, which is the accelerometer. And let's just observe how you use this accelerometer. And I'll just show you how you observe, how you take reading. Just see, I have used a mirroring software where what my screen of the phone is actually visible even on my laptop screen. So that helps at times when you are performing the experiments to be able to observe the data on your screen. So I'm not getting into the detail of that. You can always search for mirroring softwares and just observe how the accelerometer sensor is used. This is the symbol for accelerometer, and when you press on these, then there are 3 more symbols which appear, which is like X orientation, Y orientation, and Z orientation. So you can measure the acceleration in different orientations, and this is how you do. So when it is in the X orientation, means your phone is moving like this, okay? And in the Y orientation, your phone is like this. So your phone is the object which is moving and whose acceleration is being recorded. So why do you think when you keep your phone in your lap in this orientation, it is showing around 9.8? Why do you think the phone, the accelerometer sensor is showing 9.8 meter per second square? I'm sure you can identify this value. So the gravity
Gravity.
is acting on. Yeah,
Somebody
very,
is speaking. Somebody is giving answer. Yeah,
very
please,
good. Yes,
students.
yes, please. Yeah, actually, I heard you are right, Vita. It's gravity which is acting on the phone, and that's what it is sensing. Very good. So, moving ahead, you can actually press the record button to record the data. And don't worry when you started and when you have to end. So, when you press the record button, it starts recording. The screen, this part will appear slightly reddish. And then you can stop the recording and the data will appear. And then these are three dots. You can actually use the crop application and crop whatever data that you require. Okay, so actually when you start using it, it's like really simple. Please explore, and there are a number of things that you can do with these applications. So next, I move on to the other application of this is again I'm showing the various orientations in which you can record the acceleration. So depending on how you have placed your phone, the acceleration data will be collected. So Gayatri, are you ready to show your experiment, to talk about
Yes.
your experiment? Yes, over to Gayatri.
Okay, so in this first experiment, we can see a toy car that has a phone attached to it. The phone has the Arduino Science Channel app open to the accelerometer tab on the y axis. So this app tracks the phone's motion to determine its acceleration. It's important to note that the phone has to be attached to the moving object to ensure that the data is being tracked smoothly. Now, as you can, ma'am, can you please go to the next?
Yeah. Should I start the video?
No, ma'am, the data for the previous experiment.
Okay, sorry. There is the data. Why isn't it showing?
I think the slide has been
Oh,
removed.
somehow the slide has been removed. Okay, sorry for that. But yes, you could record the data, and I don't know where has the slide gone. This is the data. Yeah,
Yeah.
yeah,
So as you can see from this data, the acceleration is at zero for about a second. And through this, we can infer that the car was initially at rest. After this, the acceleration increases and decreases at a very short interval of time. Why does this happen? This is because to facilitate the car's motion, I had to push the car by applying some force. This pushing caused an initial jerk motion. Jerk is the rate of change of acceleration and occurs when the acceleration sharply increases or decreases at a very short interval of time. After this, the car starts moving at a constant velocity, as can be seen when the graph touches zero again. But after a few seconds, the car again experiences a jerk. Any idea what could have caused this?
yeah.
Students actually is asking that why there is jerk over here again.
What could have caused that? Like she just had made the car move with the phone on it. Okay, Gayatri, I think you'll have to reveal.
Okay, so it's quite simple. The car had actually hit a wall while moving straight. So that is what caused another jerk reaction. So, see, with the Science Tunnel app, it becomes extremely easy to record and analyze the motion of different objects at very short intervals of time. Now, before moving on to the next two experiments, I would briefly like to explain the concept of weight and how it applies to freefall. So you see, our weight on Earth depends on our mass, which is how much matter we are made of, as well as the force of attraction between our mass and the mass of the planet Earth. So this attractive force, which is more commonly known as gravity, is a non-contact force and acts on us from a distance. As the name implies, a non contact force is one that acts between two objects that are not in physical contact with one another, which means that we don't have to be touching Earth for gravity to be acting upon us. In fact, we do not feel the force of gravity unless there is some opposing force, opposing contact force to counteract it. This opposing force is termed as normal force, which is in contrast to gravity, a contact force, and acts upon objects that are physically associated with each other. For example, say we are standing on a football field. When we are standing, the force of Earth's gravity pulls our body towards the ground. However, because our feet are in physical contact with the ground, there's also a normal force pushing upwards on our feet. And we're able to perceive the force of gravity as weight. Now, say if the football field suddenly disappeared. Gravity would still be acting upon us, but we won't be able to sense it anymore. And this inability to feel gravity would make us feel weightless, but only for a very short moment. Ma'am, can you play the video?
Yeah.
Now, in the second experiment, you can see that the phone is being dropped from a certain height. But how do we measure the height of drop? We can do so again by using the accelerometer tab set at the z axis to study the free fall and measure the extremely short intervals of time to figure out the height, which otherwise would have proven to be quite difficult. So, this data over here shows that the object was dropped at about 2.4 seconds where free fall was initiated. The graph is touching zero because the sensors cannot register any acceleration as the object is itself being accelerated at 9.81 meter per second square, which is essentially free fall. By measuring the time interval of free fall and using the equation s is equal to half gt square, one can easily measure any height by dropping the phone from that height. Though it's very important to note over here that we have to always have some safety equipment like a soft cushion or something like that to support the falling phone from sustaining damages because we don't want to crack our phone for an experiment, right? Um, so, now can you move to the next slide?
Should I play the video?
Yes, ma'am. You can also play the video for the next one.
Yes, correct.
So, yeah. So, in this last experiment, I have recorded the motion of a lift going upwards and downwards. As you can see, I had to tape the phone to the floor to get the best data, otherwise, there would be a lot of inaccuracies. As the lift is accelerating upwards for a very short time interval, the acceleration of the lift is more than g, and we suddenly feel heavier. But when the lift is accelerating downwards, the acceleration of the lift becomes less than g, which makes us feel lighter, even if it's for a very short interval of time. And this data also shows that the phone is moving at a constant velocity, and acceleration is normal around 10 meter per second square. So, the accelerometer option in the Science Journal app is a great tool for carrying out a lot of investigations with ease, and it also gives appreciable precision.
Great. So I think there are no questions for this. If there are any clarifications required, children, you can ask. So I'll just show again. This is like downward motion. Acceleration was less than zero. I mean less than 9.8 while accelerating downwards. But when the lift was accelerating upwards, this is what Gayatri recorded, that acceleration was more than 9.8. Okay. Thank you, Gayatri. And next we move on to Maurya. Maurya, are you there? Can you share your screen and start describing the experiment that you have performed?
my presentation is related to gravity and mass of an object. So the aim of my experiment is to study how the speed with which a body hits the ground on being dropped from a certain height depends on its mass. So the materials which you need for this experiment are Firefox, the acoustic stopwatch feature, a scale, and two balls of different masses. One can be lighter than the other. So an acoustic stopwatch is basically a feature which starts a stopwatch when a sound is created and stop when another sound is created. So in my experiment, the stopwatch is started when I drop the ball, and it is stopped when the ball hits the ground and it creates another sound. This is a very good tool to measure the time taken for an object to fall. So this is my experiment. So this is a tennis ball which I took, and I took a scale. So as soon as I hit the scale, the stopwatch will start, and when the ball hits the ground, the stopwatch will stop. So there the stopwatch stopped at zero point 0.4 seconds. I did the same thing with a football. So I basically snapped the football, and the sound which my snap created started the stopwatch. And when the football fell, it stopped the stopwatch as well. So both of the times were identical, as you must have observed. And if you drop both of them at the same time, they both fall and land at the same time, even though they have different masses. So the main observation from my experiment is that the speed at which an object falls due to gravity, it does not depend on the mass of the object. It is a constant quantity. So an explanation for this is that the value of acceleration on Earth is around 9.8 meter per second square. You can round it off to 10 meter per second square. And the speed at which the object falls down, you can take it as v is equal to u plus at. It's a formula. So v is basically the final velocity of the object, u is the initial velocity of the object, and at are the acceleration and time. So in our case, u will be 0 meter per second because I drop both the balls from rest, and acceleration is 10 meter per second square. And the time, which we measured by Firefox, is 0.413 seconds. So if you substitute these values in the equation, the answer will be the same for both the objects, regardless of their mass, and the final velocity will be the same. So what I want to prove from this experiment is that any object, regardless of its mass, will fall at the same speed uh, in the same conditions as another object.
Yeah, great,
Thank
Maria.
you.
So basically, what children normally do in numericals, you have proved that when two objects of different masses are dropped from the same height, they land the ground with the same speed, right? And the short interval of time can be easily measured using this acoustic stopwatch application in the FeeFox app. Great, thank you so much. And over to you, Kashvi. Will you be presenting your screen or should I do it?
Yeah, I'll just go ahead and present my
Yes,
screen.
please. Great.
Right. I hope everyone can see my screen if
Yes.
you
Yeah.
can be confirmed. Yeah.
What is there?
All right. So just to give you a little introduction, I'll be demonstrating the bouncing ball experiment. Right. So what are we observing with the bouncing ball experiment? Here we're looking at the concept of inelastic collision, right? So just to give you a brief, inelastic collision is just basically when two objects collide, and with that, some energy is lost or transferred to the surroundings or transformed into another energy, right? Basically, energy is lost, right? So this is kind of what the concept will be exploring with inelastic collision. Um, so if you guys have the Firefox app open, you can go ahead and follow along with this. So when you open the app, um, you can scroll down to mechanics and open inelastic collision, right? Now here, from what you can see, there's also a remote device, which is the laptop. There's two devices. Basically, you'll have the same data. So if you want to go ahead and do that, so basically what you will be doing is that if you click on the three dots at the top right corner, you can go and click on having a remote device, which will send a link to your laptop, and then you can open it on a remote device. You don't have to do this. You can just use your phone, of course. Right. Uh, so what next, right? We'll move on to the demonstration of the experiment itself. Now, as I told you, it's an application of inelastic collision. So the next step that will be done is that if you can get a bouncing ball or any sort of circular object which can bounce, you can go ahead and get that. And what you have to do here is that you have to drop the ball on a surface where you can hear sound. So, what this app will basically do is that it will record the sound and it will be measuring that with each bounce that hits the surface. So, this will be conducted through the sound sensor that we have on our phones, right? So, with every audible bounce, it will be able to record the height and the time as well, as you'll see next. So basically, you have to drop the ball from a certain height on a surface or on the floor, right? And instantly, with every bounce, you will get some data. So this is the data that you will be able to see. You will be able to see the height and the time for each bounce, or the time interval for each impact to happen, right? You can also view the energy of the amount of energy that there is, percentage of energy with each bounce. And when you've done that, so when we're in a lab setting, right? Um, so I think for the past couple of years, we haven't been to school, and we've always been in, like, if you've been in a lab setting, you'll know that when we have those stopwatches, right, we're manually controlling them. Here, all of this is done by the app. So there's the only thing you have to control here is the play button, and that too you only click once, right? So when we used to be in labs, I think maybe some of you can relate, maybe some of you can't. So at least from what I remember, we used to take down the stopwatch recordings and the height and everything from like handwritten, right? So here all the data is given to you, and basically what you'll be doing is just that you're going to record the data and you're going to save it. So again, you're going to click on the three dots and then save experiment state, which will automatically save all of your data in a different collection. So if you're doing a project for school, or when we're doing practicals or IO, for example, if like I think some that we have IOs and everything. So during that, you can just record the data, and this will be helpful in that term that you won't have to do the recording again and again, right? Because from what I know and what from what I've done in labs and everything, everything was quite manual, right? So we took down everything like handwritten, and that's why it kind of produces inaccuracy as well, because when we were in labs, we had manual stopwatches. So this also eliminates that kind of inaccuracy significantly, because as you can see with the time here, that it's a very small amount of time. It's less than a second with each bounce that happens, right? uh, Now that we have the data, what can we find out from this? So I'm sure at some point during your childhood, or maybe at some point, when maybe even when you're playing table tennis or even in general tennis or something, right? uh, we often notice that the ball, when it is served for table tennis, for example, when the ball is served from the racket from one side, you do it at a certain height, but when it reaches the other side and when the other player hits it, it's at a much lower height to what had at what height it had been served, right? Now, at some point, a curiosity, well, I definitely had a curiosity where that why doesn't it reach back to the same height, right? Even during our childhood, when we had those crazy balls where you would bounce it on the floor and it would go really high and then it would come down to a very low level, right? As a kid, I also had that curiosity. I'm sure some of you must have had that curiosity. Now, this is the, like, from looking at the data, we can kind of see why that happens, and I'll give you a little explanation of that as well, right? So we can see that with each bounce the height reduced, right? So from where it started at 97.02 centimeter, it kind of went down with each bounce. Now, why does this happen? Now we can here look at the data of the energy as well, right? Now, as you might notice that everything is on the screen here, that the energy itself is decreasing, right? I give a little brief on inelastic collision where two objects collide and some energy is lost. You can kind of see the application of that definition itself here, because as you can see the percentage of energy is going lower with each height. So that's how these things are connected, like, or maybe how is it connected, right? Because we can see that both the values are going lower, right? uh, so this is how it's connected. I'll just explain it if you're a little confused. So as we can see, the energy which was at 100% with when the ball was released, right? It had 100% of its energy. But as soon as the first bounce happened on the impact, uh, the kinetic energy upon impact was lost somewhere. But where was that kinetic energy lost, right? So some of the kinetic energy was gained back by the ball, hence why it was able to go back to 81.5 centimeters. If you look at the first bounce itself, right, from the initial height to this height one, we can see that it did go back to 81.5, but not 97.02. Why? Because some energy was lost, right? And some energy was absorbed back into the ball. But when the ball hit the ground, energy was lost. And through the energy that was absorbed back, the ball was able to bounce back, right? And another thing we can note here is that as we can see, the detained on collision energy, right? So not 100% of the energy is recorded again. From whatever the energy was left, that from that itself, the energy is lost, right? So what can we find out from this, right? What can we use from this data? So from this data, we can find the acceleration due to gravity, which is g, as well as the coefficient of restitution. So Neeraj ma'am, if you can take over here to explain a little about the formulas itself.
Yeah, right. Thank you, Kashvi, for explaining so beautifully. In fact, that's why I wanted you children to explain, because this is the way the student would think, observing why the ball doesn't bounce back to the same height. And I appreciate that you've actually been always curious to find out the reasons to this. And this data collection helped you to analyze that the kinetic energy was lost at every bounce, and that kinetic energy must have been converted to sound or heat energy, and so it bounced back with lesser kinetic energy and so gained lesser height. At every bounce it was actually losing kinetic energy. So as you can see on the screen, that coefficient of restitution is actually the percentage of energy, or the ratio of the energy which is lost at every whenever the ball hits the ground. And that, when we calculate doing some bit of mathematics in grade 11, it is under root of the second height, the bounce height, to the initial height from which it was dropped. So if you try to do some quick calculations, you'll notice that every ratio, 81.5 upon 97.02 or 68.46 to 81.50, is coming out to be almost 0.84. And so the under root of that gives you the coefficient of restitution, which is 0.92. That's how you can calculate the coefficient of restitution. And how do we calculate the value of acceleration due to gravity using this data? That also can be calculated. If you look at the figure, see, the ball was dropped from 97.02. It hit the floor and bounced back to 81.50. Actually, this application works on the same principle that Maurya had explained, that was acoustic stopwatch. That means when one sound is produced, the timer starts. And when the second sound is produced, then the timer stops. So that means 0.815 second was taken for the ball to go to 81.50 and come back. That means it has taken half of that time to reach that second bouncing height. And so knowing that time, which was 0.41, half of 0.815 is around 0.41 seconds. So using that particular time in this formula, S is equal to ut plus half gt square, you can understand u is 0. And the drop, this height is 81.50. So it's like coming down from 81.50, drop in its free fall. It has taken around 0.41 second, which is half of 0.815 second. And we came to the calculation to be very close to 9.8, which was 9.76 meter per second square. Right. So this experiment can be used for a number of such applications. VFox is actually a beautiful, I would call it beautiful, it's a wonderful app which utilizes a lot of sensors, and it's very user friendly. If you start playing around with it, it has also the videos of each experiment. You can just follow the instructions. There are also the concepts behind each experiment which is explained. So if you, like Maurya, use the application acoustic stopwatch, and then what Kashvi has described is the inelastic collision. I'll just take you through another experiment. Do we have time, Vinita? If we have, then we can.
Actually, you must at least give a brief, because this is not the end, Neeraj. You and Ravi sir have to do a lot, and I will also join, because last year we did a lot of exploration based on app. But you must, because all students who are from Vidyagan and different places, obviously they will want Dil Mange more, and we will have many such sessions.
Yeah. So I'll just quickly take you through these videos which are describing other experiments that we have performed. This is the application centripetal acceleration of VFox app. So this is a salad spinner, and I'm going to rotate my phone within that salad spinner. And then using the remote access in the application, we can actually see the data here, because I'm not able to see my screen because the phone will be spinning inside the salad spinner. So the remote access helped there. Actually, VFox, this application is really good, because which is not there in Science Journal app. That is why I was using a mirroring software to see the data in this screen. But here we have remote access. It gives you a link. That link you have to type on the laptop, and you get the remote access. So just observe the video. Sorry. So you use centripetal acceleration and use remote access, allow remote access. There will be a link. Use that link. I've already inserted the link over there. And I'm going to actually play also using remote access. And I have enough padding for the phone to be placed in the salad spinner so that it doesn't move from its position, and it can easily spin without actually, spinning around on its own axis. So when I spin the phone, then the data is recorded. I've pressed the play button using remote access only. Okay, so you see how quickly the data is collected. There is no manual plotting of graphs. I'm getting the graph right away.
Students can do even exploration in rotational dynamics.
Yes.
This is something very great, and I'm seeing for the first time this particular one.
Yeah. So the data that I got was, I'll show you the data. Yeah. This was the data that was collected. This is a screenshot of my phone when I did that experiment. So this one is acceleration versus angular velocity graph. You know, this is the relation between acceleration and angular velocity. So this is the curve that we are getting. And then there is acceleration versus omega square. And this is a straight line that I'm getting. So what will I find from the slope of this straight line? Any guesses? What can I find from the slope of the straight line? A upon omega square will give me the radius in which my phone is rotating, and I tried actually finding out it was matching with what I calculated from the slope. So you can find the radius of the circular path using this graph. Okay. Then quickly this is the last experiment, although there are many more, but I'll just show you this. This is the setup that we did. It's like there is a spring and the phone is tied to the spring, and you have to make sure that your phone doesn't get damaged. So it has to be properly placed like within this cardboard, and then there are some weights attached to it. So when I pull the weights down, the spring will start oscillating. And this is simple harmonic motion, and you'll be amazed to see the visualization of the simple harmonic motion. So just observe this video. This video may not be very clear because that's taken from my phone, but I'm sure the idea will be. So this is the simple harmonic motion which is observed when the phone is oscillating.
Neeraj, have you connected your phone with a Bluetooth to the laptop? Because graph immediately
No,
the graph
this is
up.
remote access. This FeeFox has this application I just mentioned. This has remote access. So you just put the link in your laptop, the screen will appear there.
Using internet connection, using Wi-Fi, it takes the data from the phone to laptop.
Yeah. Thank you. So then this is the data that I got. I changed the weight that I attached. 170 gram was approximately the weight of my phone, in grams. And when I added 200 grams, this was the time period which I calculated from the graph that I obtained. And this I thought can be used to actually calculate even the spring constant. So the lot of data can actually be collected because I had only a few of these weights at home, so I could just take this much, but more data can be collected by using more of these. So I think there is one more application you can just try. This is roll. I would just like to show you. This is, I think, 30 seconds. I have 1.5 minutes video. So roll, when I use the roll application and allow remote access, then I'll get the graph on the screen. And what I did was I had to roll my phone. So I took this cylindrical cardboard box, measured its diameter, different readings taken so that an average diameter can be calculated. And I had to insert the radius of this in the screen.
I'm thinking of changing radius also, sticking this mobile to one side and rolling and doing exploration.
So now I could, there was no way of calculating the angle. So I just measured the height of my inclined plane that I created on my writing table and this length. And then I had to put my phone in nice woolen socks so that it doesn't get damaged when it is getting rolled. and then I inserted it in the cardboard box and I rolled it on the inclined plane. And then in a jiffy, I got the graph. So what I am trying to say is that a lot can be done. It's just a matter of spending some time and using your own creativity and designing your own experiments. A lot can be done. So it's just that I'll roll the phone and then the graph can be studied. Okay. So I think I'll stop here. We've already crossed the time. And that is all that we have for the day. If there are any questions, if anybody would like to stay and have any questions,
there was one hand raised. There was one student who was asking a question.
Yes, please.
Yeah, somebody was raising hand that time.
Kaustubh. Acha, Kaustubh has left the meeting. Sorry.
Okay. Before anything or any more thing we start think of doing, I would like Rishabh to speak first, and then obviously we will come to Shiparna ma'am. Yeah, Rishabh.
Sorry, Vinita, even I would like to add some lines.
Yeah, sure.
So that was certainly a very interesting session, ma'am and team. And I'm sure we'll all be using some of these methods that you showed to us to perform experiments ourselves. I would like to thank you for this wonderful session. And Vinita ma'am, a few words. And
yeah,
then
I just want to listen from Vidyagam students because there were many Vidyagam students who joined. Neeraj, I was just thinking, Gulfam sir, are you there? Yeah. So was just thinking that if we can organize many such sessions, because see, in IB we do use all this app and do experiments while teaching. Is some Vidyagam student in this team still there? Can I hear from you? How was the session? Is the fear gone or still there?
I just hope there is some fascination created. If not, the fear is completely gone.
Yeah. With Vaishnavi, over to you, Vaishnavi.
Yes, ma'am.
So, would you like to download that app and learn more, darling?
Yeah, ma'am.
Would you like to have more session?
Sure, ma'am.
So, a big clap to me. Yeah, speak up.
Maybe we'll have some of these students demonstrate.
Yeah, but they will demonstrate. Gulfam sir is also champion in this. So, Vaishnavi, I would like to listen from you. Do you want actually exploration?
Yes, ma'am, because it was wonderful session and we enjoyed it.
You enjoyed it. Thank you. Thanks a lot. Sonia is there. Would just take one more thing. I just want to add here. For all those IB students who are there from both the campuses, the recording will be uploaded. Those who have missed, please inform your friends they must check it, because this is the time you start exploration. Last year also we were sitting at home and we used this app for all experiments, and all exploration were app based. And a big clap to Neeraj ma'am, and especially to 3 kids. They were so spontaneous. They were so good in explaining. Neeraj ma'am, hats off to you. The way Kashvi and all the other 2 students, where are you? I can't see you in camera.
No,
the way you,
Maurya, Kashvi, all of them did a fine job.
Would like to listen first from Krishnan sir, and then to Shiparna ma'am, and obviously Sonia ma'am is there, whom I have handed over from fear to fascination. Sonia ma'am, and they'll say, yeah, Krishnan sir.
Can you hear me, Vinita?
Yes, sir.
Okay, good evening, all of you. Especially, I'd like to congratulate Miss Neeraj, though I am speaking to her first time. And believe it, I was sitting here for the last 1.5 hours, and but I had some other work. I thought, no, this is called as the curiosity. I want to see what exactly is happening. So that's why I could not move from place. That is one thing. Now, I would like to take 5 minutes because I want students to think in this perspective also, okay? Because reason is, I know the time is a constraint. First and foremost, Ms. Neeraj and your students, if you can conduct this session on Saturdays, believe it, it will be a great help, because Saturday it's basically off. And moreover, right now we have the limitation of the timing right now. At least on Saturdays, we can even go for 2.5 hours or 3 hours. Okay, even students can come and they can participate maximum. So that's one of my suggestions from my side. The time will not be a constraint on Saturdays or any. My message was Saturday or any holiday. So that will be always good. Second, especially for the international curriculum students, especially for the DP students, since they have the students from Noida as well as from Gurgaon. Okay, now students, please understand. I'll try to wind up in 5 minutes. I know when you talk about physics, okay, I hope you are aware about this. Physics and mathematics, they got a huge relation here. Coincidentally, fortunately, I'm from mathematics background. Okay, so in that sense, I will be able to give you some kind of insights on that. See, when you talk about the IB curriculum, especially physics or mathematics, one of the prime requirement is your internal assessment. It's always said that the IAs or the extended if you are doing in maths or physics, that is always considered as one of the toughest IA. You know why? There are certain things. One, the basic challenge with the physics or mathematics is the topic needs to be decided. Okay, if you have decided the topic, believe it, at least 20% of the work is done. That itself takes a lot of time. Okay, now when you say when you see these kind of experiments and everything, it gives you a lot of ideas. Okay, probably this could be my favorite topic. I can go ahead with this topic. That is one. Once the topic is done, the next challenge always comes with you is called as the data. The word is data. Okay, now if you see this experiment now when you talk about data, it gives you beautiful experiments in which a lot of data can be created, especially the primary data. When you get the primary data, you know that a lot of scope is there. You can easily progress in your internal assessment in your respective subjects. Also in mathematics, I'll tell you, if you are very much interested in physics, that data you can use it in your mathematics exploration as well. That data you can use it. Okay, I can see the light sensors, that one of the experiment what ma'am has shown, one of the student has shown related to the sound sensors and so on. It all leads to data. So when you got the data, it leads to some of the modeling. Some of the modeling means it generates some kind of curve, some kind of line. Okay, when you talk about curves, line, it all leads to the direction of mathematics here. Okay, so it's a beautiful scope. Another biggest advantage in in these kind of experiments, I don't know whether you observed or not, when you perform primary experiment, right, you are aware about the limitation of the experiment, and you can easily fix that, which will lead to the accuracy. Plus, you can also go for the validity. This is what I observed in the last 1.5 hours. You can check the validity of the result also. So believe it, this evening is really wonderful session. I think it should continue in the coming time also. It will be a kind of great help for each and every student in IB, especially your physics part as well as the mathematics part. It will take care of both the subjects. Okay, believe it, your brain will open which experiment to choose, and how do you go ahead with some kind of simulation which will create some kind of data, and believe it, that will lead to one of the quality IA or the extended that you can submit in physics or mathematics, and obviously end of the day you will be getting one of the best marks. So that's my point of view to all of you. Thank you.
Thank you, Krishnan. I just want to share that next session will be taken by Arpita, who is from our campus, who is also Maverick about app, and that session will be in bio exploration. So, and then obviously this is not going to end. Neeraj ma'am and Ravi sir also they know a lot of app-based experiments. We will fix something like what you have suggested, a great idea on Saturdays or a holiday. Also, Gulfam sir is actually design a lot of experiments. So there is no, we all are so well equipped. We are so well informed. So if students can gain on Saturday, why not? So thanks a lot, Krishnan, for suggesting such a wonderful idea. We will work together and see that it happens. Would like to listen from Shiparna ma'am. Shiparna ma'am, are you there?
Yes, I am here. It was a wonderful session. I have nothing new to add except that I was really, really amazed with Neeraj ma'am and her team of the students who did a wonderful job. And what I would like to add to what Krishnan sir said, this was like a trailer. For a person like me, I was not able to follow a few things, but then I took screenshots so that I can understand later. And I thought, okay, since they are there in my campus, I will ask whenever I have doubt. But what I felt when Krishnan sir is mentioned this, since this was like a glimpse, giving a glimpse of all that can be done, maybe on Saturdays when we perform, it could be like a workshop where students register and come and actually perform, and it takes a little longer, and it can be like a workshop. Yes. I think even the student mentors can, because they were doing excellent job. I think they can also take one session parallelly under the guidance of all the physics faculties and Neeraj ma'am here. I think it's a wonderful thing and we should never stop. Very good. Excellent.
Thank you, Shikarna. You are my biggest strength, since last 15 years. Love you a lot and love all the physics educator and students. One thing, Shikarna, I would like to mention you that Jayati ma'am was asking, is there some, that Ravi sir will tell me or Neeraj ma'am, is there some experiment which can be done in chemistry? Bio session will be taken by Arpita ma'am, who is also very good in app-based experiment, who is from our session. Is there some app, Ravi sir and Neeraj ma'am and Gulfam sir? I'm going to stop the recording so that we can discuss just for 1 more minute this, so that chemistry experiment can be done. Over to you, Ravi sir.
I think I need to look for it before like